Alright, let's start with number 15. Goal here is just to simplify by taking the roots of the numerator and the denominator. So number 15 is a square root, or radical, 36y cubed over x to the fourth. Remember that this also can mean that you can take the root of the top over the root of the bottom. And as we said before, we can take root of 36, which is always 6, always the positive one. Since it's the square root, imaginary 2 right here, 2 goes into 3 how many times? Goes in once with a remainder of 1. So y to the first left underneath your radical. On the bottom, square root of x2 goes in at 4 twice. So x squared comes out with no remainders, and that's your answer for number 15. Number 20. Fourth root of 81, I'm just going to do my work over to the side now. I know 81 factors to 9 and 9, which is the same thing as 3, 3, 3, and 3. So there's my work, which is the same thing as 3 to the 1, 2, 3, 4. So fourth root of 3 to the fourth, x to the fourth, all over fourth root, y to the eighth, z to the fourth. Forgot my fourth root there. Fourth root of 3 to the fourth is 3. X to the fourth is just x. And the fourth root of y to the eighth is y squared. Fourth root of z to the fourth is z. Number 25. Sixth root of x to the sixth, we know is x. Sixth root of y to the eighth, well, 6 goes into y to the eighth, goes in once, so only one y comes out with a remainder of how many? 2. 6 goes into 15 twice, so that means you get z squared coming out. And what do I have left over? I have z to the third left over. Other thing you can do here, because you have something to the sixth power, this also means that we can turn this into a rational exponent. So let's try doing that. This is x times y to the what? The 2 is your numerator, 6 is your denominator. I'm going to leave that there for right now. So what is that? This is y to the 1/3. This is x, y to the cube root of y. On the denominator over here, you had z squared and z to the 3 over 6. 3 is your numerator, 6 is your denominator, which is the same thing as 1/2. So we got z squared root z. Now this part is a little excessive. I actually only need you to go to this step, but it's good to know how to do these as well. Alright, let's move on to number 30. Well, there's no cube root of 5, there's no cube root of 40, but because they are separate, we can also put them together because they are both of an index of 3. So this is cube root of 40 over 5, which is the same thing as cube root of 8. And we know that 8 is the same thing as 2 cubed, and the cube root of something cubed is itself. All right, 35. It says divide and, if possible, simplify. So let's put our roots together. The 5 is going to stay outside. I'm actually going to separate that into a completely different fraction. See how it's still in the denominator? But this is all going to go under 1 radical. So 100 AB over 2 is the same thing as 50 AB. No more denominator because 2, this will become a 1 if I cancel. And we got 50 AB, well, square root of that. This is the same thing as what? 25 times 2 AB. This is not going to simplify, but my 25 will. 25 simplifies to 5. So this is 1/5 times 5 root 2ab, which will be the same thing as 1/5 times 5 is 1, so 1 times radical 2ab. Not too bad. I'm sure you had a question on 40, and on 40 it did say that a hint was to factor first before you simplify. We know that we're going to put this all under one radical, so I'm going to do that first. Remember, r cubed plus s cubed, what is factor of cubes? It is first term plus the second term. So this one, remember, is plus minus plus r squared rs s squared all over r plus s. Even though it's adding, it's the entire quantity multiplied by the entire quantity. So cancel, cancel. This is going to be the cube root of, because this is just a 1, r squared minus rs plus s squared. And that's number 40. Alright, we're getting to the part where they want us to rationalize the denominator. Rationalize means I want to get rid of all of my radicals. It's almost impossible to get rid of all of your radicals on top and on the bottom. So usually they'll just ask for one. Right now they want the rationalization of the denominator. In 45, if we have cube root of 16 over 9, then we're trying to get rid of this cube root over 9. One thing that you want to do, it kind of helps to keep everything under this cube root. You can do it the other way, and I'll show you the other way in a second. But you also want to factor everything completely. So this is the same thing as 2 to the 4th. That's 16. 9 is the same thing as 3 squared, right? This number, the exponent, we want to match it to the index. So how are we going to match it here? Well, I have to multiply the bottom by another 3, because that's going to give me 3 cubed, and then I can take the cube root of that. But whatever I do to the denominator, I have to do to the numerator, which leaves me over here with cube root of 3 cubed and 2 to the 4th times 3. Separating this out, cube root of the denominator is 3. Perfect. Done with the denominator, it's rationalized. Now I just have to simplify my numerator. This 3 goes into 2 to the 4th, goes into 4 once. So 1, 2 comes out. Left with 1, 2 and 1, 3. So my final answer is 2 cube root of 6 over 3. Number 50. 50 is a cube root. 3a to the 4th over cube root of 7b squared. Now here, it's already separate, so why don't we try doing it separately? To rationalize the denominator, how am I going to get that b to the 3rd power? Well, I have to multiply by one more b, right? But not just the b. It's got to still be in that cube root, otherwise I'm not going to be able to multiply it to each other. So I also have to do that to the top. 1b. What else do I need? Well, I have 7 to the 1st. That doesn't factor. So to get it to 7 to the 3rd, how many more do I need? Need 2 more. So let's multiply top and bottom by 7 squared. So here on the bottom, I'm going to get the cube root of 7 cubed b cubed. And on top, we have, well, 7 squared is the same thing as 49. 49 times 3, 147. A to the 4th b. Cube root of 7 cubed is 7. Cube root of b cubed is b. Cube root of 147, well, it's just 7 times 7 times 3, so I don't believe there is one. 147. I can take out an a, because 3 goes into 4 one time. So we got 1 a to the 1st outside, with 1 remainder a, and a b outside. You have root 9 over 20x squared y. That's all under 1 root. And because this square root, we're not looking for cube roots, we're just looking for square root. When I split this apart, I want to simplify as much as I can first. So on top, I have a 3. Square root of 20 is the same thing as 4 times 5x squared y. And I can pull out the 4 because the square root of that is 2. Pull out an x because the square root of x squared is x, with the root 5y left over. Square root of 5y. Nothing there, so in order to make sure, remember that this is a 2, to get a 5 squared, I need one more 5. To get a y squared, I need one more y. Whatever I do to the bottom, have to do to the top. 3 root 5y over 2x. This part gets a little tricky. Square root of something times square root of something is just that one thing. It's not going to be 5y squared. It's not going to be 25y squared. The square root of something squared is itself. Distribute, or not distribute, just multiply, and you get 10xy as your denominator. All right, number 60. Rationalizing a numerator is exactly the same as rationalizing a denominator. You're just getting the radical out of the numerator instead of the denominator. Hence its name. 10 does not factor to anything that's a perfect square, since we are just taking a square root. It's just 5 and 2. So we do the same thing that we did to the denominator. How are we going to get 10 squared? What do we have to multiply the top by? Well, we have to multiply by the square root of 10, because underneath that gives us 10 squared. Underneath here, multiplying together, you get 30x. Root of 10 squared is just 10. You don't need, or you can assume that it's positive because that's what the instructions tell you to do. So no need for absolute values on any of these problems. 65, 2 more to go. Cube root of 7 over cube root of 2. Cube roots, a little bit different because this is the same thing as cube root of 7 to the first over cube root of 2 to the first. So how do I get this to 7 cubed? Well, I need 7 squared. Cube root of 7 squared. To the top and to the bottom. That way I have the cube root of 7 cubed over, well, 7 squared is 49 times 2 is 98. So we got cube root of 98 here. Cube root of 7 cubed is just 7 on its own, and you got your cube root of 98 here. And finally, number 70. Cube root 2a to the 4th over 7b. Still trying to rationalize the numerator. Let's separate these out now because I know that I can take one of these a's out. Cube root of a to the 4th is a. Cube root of a. Nothing you could do to that 2, and nothing you can do to that 7b. All I need is to rationalize this 2a now. The 2 to the first and a to the first, what do I have to multiply by? Cube root of 2 to the and a to the second. Whatever I do to the top, have to do to the bottom. 2 squared, a squared. So now I have a cube root of 2 cubed, a cubed, perfect, over the cube root of, multiplying through, 2 squared is 4 times 7 is 28. I got an a squared there and a b. Nothing down there simplifies. This will simplify to another a, that's from here, times 2a, that's the cube root of this, over cube root of 28 a squared b. And this is 2a squared over cube root 28 a squared